deriving the sine rule. The sine rule is actually proved by using right-angled trigonometry, and we're going to do that here. Here I have any non-right-angled triangle labelled correctly, A, side A, angle B, side B, etc. If we wish to prove the sine rule, divide or drop a line perpendicular to AB from C. As it is perpendicular, this is a right angle. This comes in at point P, and we will call this H, the height of this triangle. This does not necessarily bisect or cut in half AB, because that would only work if A and B here were the same. So we've just dropped this down to make two right-angled triangles. Now, if you just consider this triangle, so I'll actually just draw that so we can be quite clear what we're doing. I don't know what this side is called because the whole thing is C, but this is not C anymore because it's a smaller part. If we look at angle B, sine of that angle is opposite over hypotenuse, so sine of angle B is H over A. So if I rearrange that to be in terms of H, H will be A sine B. And that's just from that triangle. If I then go to the other triangle, triangle ACP, you don't actually need to draw these. I didn't put in a right angle. I'm just drawing them so it's clearer what we're doing. That is angle A, and I've got B and H, and again I don't know what this side would be called because it's definitely not C. Now we're going to look at angle A. As we know, of course, sine of the angle is opposite over hypotenuse, so sine of angle A is H on B. And if I rearrange that to find H, H is B sine A. Now what I've found here is that H equals A sine B and H equals B sine A, which says that, A times sine B is equal to B times sine A. If I divide both sides by A to get sine B on its own, sine B equals B sine A on A. And if I divide both sides by B, sine B on B equals sine A on A, and that is the start of our sine rule. Up here instead, I could have divided both sides by sine B and both sides by sine A to get A on sine A equals B on sine B. So these are totally equivalent. They both come from this, which is why we can choose to use this one for finding an angle and this one for finding a side. And I can also do the same proof, cutting the triangle this way and relating C and B, or cutting the triangle this way and relating C and A, and discovering that they are all equated or related in this relationship. So that is how we use right-angled trigonometry to build the sine rule.